Hi everybody. Thought we'd take a stab at doing an implication table given the following present state next state diagram. The diagram, if you draw it out, is a little involved, and then if you convert it into the present state next state table, it takes some time. So I've taken a shortcut here by writing out the present state next state table for you. And what we want to do here is we want to start off with the second letter in a row, B, C, D, E, F, and end up in G. And then what we want to do is start off along the rows with the first letter and end with the second to last letter, A, B, C, D, E, and F. And then we don't do G. And then what you do is you make your chart. And then you do the trivial distinct different rows. So one thing you can do is you can look from A to B, and you can see there's no difference in output, so you don't put in an X. And in fact, you can go from A all the way to D. A to D must have an X. Similarly, B to D must have an X. There must be an X between C and D, because the outputs are different. So you go CD, there's an X. There must be an X between D and E, D and F, and D and G. So D and E, F, and G. And then we don't know if there is going to be trivial differences between the other ones. And then what you do is you do row-by-row comparisons from A to B. That's A, B. So then it's A, B, and then CC. We don't write out CC, so we just write out A, B, because C is obviously equal to C. So if A is equal to B, then in principle, A and B are going to be equal to each other, and in fact they are. So that's one of the shortcuts right in there. AB is obviously equal to AB, and so we can say, aha, A equals B. Knowing as we do that A is equal to B is a big win for us, because now when we start to do comparisons, if AB comes up, we already know that it's equal. Let's try A and C. So we go from A to C, it's BD, CC. If BD comes in, BD as equal, then we can have an equivalence. How about if we look for A and E? We have AB, we know that's equal, and then comes CF. Well, we'll just write CF in here, and if they turn out to be equal later, then we can get a savings. Here's AC, I'm sorry, AF. A to F is B to B, they must be equal, and then CF. Here's A to G, that's AB, we know that's equal, and then there's CE. Now I have B to C, BC, that's AD, we leave off CC. B to E, that's AA, which we leave off, and then CF. Now we have B to F, and that's AB, which we know is equal, and then CG. Then we have B to G, that's AA, those are equal, and then CE. Then we have CE, C to E, and that's AD, and then CF. And then we have C to F, and C to F is BD, CG. Now we have C to G, that's AD, CE. Now we do E to F, that's AB, FG. Then we do e to g, AA, they're equal, FE, or EF. And then comes F to G again, that's AB, GE. And so now we've got some interesting things going on here. We know that AD is not equal because there's an X in here. That means this is not equal. This is not equal. This is not equal. That's very interesting. And then we go through it and we say, well, look, BC is not equal. So if you find a BC anywhere, you'd cross that off, but I don't see it. Then you say BD is not equal. So you go through and you say, aha, there's this one, and then there's this one. So now we have to go back. So now we see, aha, AC is not equal. Well, I don't see anything wrong with that. AD, we've already looked, and I don't see any ADs anymore. BC, these are distinct. So if BC is distinct, let's see if BC appears, and it doesn't. Then we look at CE. That's to be distinct. If CE appears, and it does. So now we've got to go back. There's the backtracking. So now I got to do AG. See if AG appears anywhere, and it doesn't. I do BG, see if BG appears anywhere, and I don't see it. I think we already did BC, but I'll just check again. I'm not seeing BC. So let's take a different approach. Is CF okay? So we look at C, and we look at F, and no, it isn't. So this has got to go, and that's got to go, and this has got to go. So now we look at CG. CG's no good, so that gets an X. And so now we're back over in here. We look at AB. AB is okay, that's equivalent. Here's one called EF, and this one says EG. These two may be equivalent. And then here's FG, it has an AB in it. AB, well, that doesn't get in there. So now the only thing left is AB. AB looks like it's AB. EG, and we go into EG, and we check it, and it looks all right. We look at EF. We see EF, and that's okay. So what do we conclude from this? Well, we conclude that E must be equal to G, and we also conclude that F must be equal to E. And we know that E equals G, so that must also be equal to E. So F equals E equals G, and A is equal to B. So what that says to me is anywhere I see a B, I can write out an A. Anywhere I see a B in a row, I can cross it out. Then I can say, aha, anywhere I see an E or a G, I can write out an F. So that means these things can all be set equal to each other, and then these rows are removed. And so that greatly simplifies your state machine. Thank you very much.